So we treat artificial intelligence like it's a ghost.
Oh, totally,
I
yeah.
mean, we interact with it through these sleek, minimalist glass rectangles, right?
Huh.
And it just feels like this pure, weightless cognition floating around in the ether.
Right, like it's just magic.
Exactly. You type a prompt, and a finalized financial model or, a fully rendered image just materializes out of thin air. We've completely bought into this whole aesthetic of the cloud.
Which is, I mean, arguably the most successful branding coup of the 21st century.
Oh, 100%.
Because there's absolutely nothing atmospheric or weightless about the AI revolution. When you actually look at the physical mechanics powering that supposedly seamless experience you get on your phone, you are looking at brutal, heavy, roaring industrial reality.
Yeah, the physical footprint is insane.
It is. We're talking about thousands of tons of reinforced concrete, massive cooling towers, and an electrical draw so intense it's literally straining national grids.
Right. So the software might be elegant, but the machine running it is just this ravenous beast. And that massive friction, the friction between the digital illusion of AI and its crushing physical requirements, that's the entire foundation of what we are pulling apart today.
And it is a fascinating document we have for this.
It really is. So to you, the listener, whether you're interested in tech, investing, or just trying to understand where this whole AI revolution is actually heading, this deep dive is going to completely reframe how you look at the physical reality of artificial intelligence. We are looking at a manifesto published on the Netizen platform dated May 30, 2026.
Written by Paramendra Kumar Bhagat.
Yes, exactly. And it outlines a pitch for a civilization-scale infrastructure project called Himalayan Compute. And the core thesis is honestly shocking if you're stuck in the standard Silicon Valley mindset.
It really flips the script.
It does. It argues that the ultimate winner of the AI arms race won't be a software company writing better algorithms. It will be a trillion-dollar utility company that figures out how to feed the beast.
The premise zeroes in on a fundamental miscalculation that, the tech industry is currently making.
Right.
We're all operating under this assumption that AI development is gated by human ingenuity or, the refinement of code.
Like we just need smarter developers.
Exactly.
Huh.
But Bhagat's text argues that the era of code being the primary bottleneck is basically over. The new bottleneck is raw physics.
Physics.
Yeah.
Yeah.
It is the availability of semiconductors, yes,
Mhm.
but even more so, it is the availability of uninterrupted baseload electricity and the physical infrastructure required to house it all.
And his proposed solution sidesteps the usual tech hubs entirely, right? Like, he's not talking about building in San Francisco or Austin.
Not at all. He's pointing instead to the massive, untapped natural resources of Nepal.
Which is just wild to think about. So let's jump straight into this because the author uses a historical framework that really reframes where we are in the hype cycle. The manifesto claims that right now, in the mid-20s, the AI industry is stuck in the steam engine phase.
It's a really sharp analogy
Yeah, I love that one.
because it forces us to look at the sequence of industrial transformations, right? When the steam engine was first commercialized, it was the absolute marvel of the age.
Like, people were just blown away by it.
Right. Everyone was focused on the engine itself, making it slightly more efficient, tweaking the valves, marveling at the localized mechanical work it could do.
Yeah.
But the steam engine wasn't the end game. The staggering generational wealth, the total rewiring of human civilization, that didn't come from selling the engines themselves.
Right. It came from what it enabled.
Exactly. It came from the infrastructure built on top of that capability. The transcontinental railroads, the mechanized textile mills, the birth of modern logistics.
Okay, let's unpack this because
Yeah.
the engine was just the prerequisite. And the text is arguing we are making the exact same myopic mistake today.
We absolutely are.
We are staring at the shiny new AI sports cars being built, right?
The chatbots, the autonomous agents, the generative video tools, we're completely ignoring the fact that we haven't built the gas stations or paved the roads yet.
That's a perfect way to put it. We're acting like these hyper-fast software applications are the finish line. The AI economy isn't floating in a magical cloud. It's anchored in heavy, physical, industrial machines.
And we are hitting the physical limits of that neglect right now, like today. The text highlights that the AI economy is currently bottlenecked by supply, not demand.
Meaning everyone wants it, but we can't make enough of it.
Exactly. You have Fortune 500 companies, sovereign wealth funds, defense departments, thousands of startups, all demanding effectively infinite compute power.
Right.
But they are slamming into a physical brick wall. The constraints are Physical chips, electricity, data centers, cooling systems, and transmission lines.
Let's talk about the mechanics of that wall, because it's not just a matter of, ordering more servers from Dell. The physics of AI compute are fundamentally different from traditional cloud computing, aren't they?
Oh, they're dramatically different. It's a whole other beast. Traditional cloud data centers, the ones hosting normal websites, SaaS platforms, databases, they are built around standard CPU racks. A high-density rack in a traditional data center might draw somewhere between 10 to 15 kilowatts of power.
Which is already a lot of power.
It is. And the facility's HVAC system is designed to dissipate that specific thermal load. But when you move to AI training and inference, you are packing specialized GPUs like the NVIDIA H100s or B200s into incredibly dense clusters.
Right, because they need to talk to each other extremely fast.
Exactly. And a single rack of these AI servers can easily draw 100 kilowatts or more.
Wait, 100 kilowatts just for one rack?
Yeah,
So
exactly.
you're talking about nearly a 10x increase in power density in the exact same physical footprint.
Yes,
Yeah.
which completely breaks the legacy infrastructure. Traditional air cooling physically cannot move enough chilled air through the servers to keep the silicon from melting.
Oh, wow.
You need direct-to-chip liquid cooling. You need massive water supplies. You need upgraded substations just to handle the localized electrical draw without browning out the local grid.
Which explains why all these massive tech companies are scrambling.
This is why the hyperscalers are in full-blown panic mode. They are committing hundreds of billions in capital expenditure because the limiting factor for achieving artificial general intelligence isn't some algorithmic breakthrough anymore.
It's concrete and wires.
It's whether we can physically construct gigawatt-scale data centers fast enough to run the massive training runs. What's fascinating here is the shift in economic power.
Right, because if the ceiling is physics and power, then the fundamental rules of economic leverage change overnight.
They do. When demand vastly exceeds supply, and supply is physically constrained by concrete, steel, and power generation, the owners of the infrastructure gain extraordinary pricing power.
Whoever controls the most efficient, massive-scale infrastructure basically holds the entire industry hostage.
It's a pure seller's market.
Yeah.
And this is why governments are panicking over sovereign AI capabilities. The constraint is no longer human ideas. It's physics and power. The text argues this is birthing an entirely new macroeconomic paradigm, which they call the compute economy.
I want to dig into that concept, the compute economy, because the author writes that in the 20th century, nations built their wealth and geopolitical leverage by exporting physical manufactured goods or commodities, right?
Yeah.
Oil, steel, automobiles.
Right, the physical stuff.
But in the 21st century, they argue the primary export will be compute.
It forces a total reevaluation of what a national resource actually is. Historically, if you had a massive reserve of crude oil, you had geopolitical leverage.
Sure.
You physically extracted it, loaded it onto supertankers, and shipped it to industrial centers around the world. The manifesto suggests that raw processing power compute is the new oil.
But you can't put compute on a boat.
Exactly. Instead of loading it onto ships, you are generating it at the source of the cheapest energy and then exporting it at the speed of light across transoceanic fiber optic cables.
That is such a wild concept.
Every drug discovery simulation, every autonomous logistics network, every national security apparatus will require a continuous massive supply of this specific resource.
Which brings us to the geographic pivot of this entire manifesto, because if raw power is the ultimate bottleneck for this new digital export, suddenly where you physically locate these data centers becomes the most critical strategic decision you can make.
Absolutely. Geography matters again.
For the last 20 years, the internet promised us that geography was dead, right? Silicon Valley, Bangalore, London, it didn't matter as long as you had bandwidth. But this text argues AI brings it back. And the author points a massive spotlight at Nepal. Not for Everest or tourism, but for power.
It's highly counterintuitive at first glance. When evaluating tech infrastructure hubs, the standard criteria are usually proximity to talent, existing fiber backbones, and stable regulatory environments.
Yeah, Nepal is rarely, if ever, on that list.
But the author zeroes in on one staggering geological advantage. Nepal possesses an estimated 50,000 megawatts of economically viable, untapped hydropower potential.
Okay, stop right there because I have to play devil's advocate here. I really need to push back on
Oh,
this.
for
50,000 megawatts of roaring Himalayan river water is a massive energy reserve, absolutely. But if you are a developing nation with that much potential power, the obvious proven economic play is to build dams, generate the electricity, and just export that power across the border, right? Sell it to energy-starved regions in India or Bangladesh.
That is the traditional thinking,
Yep.
yes.
Why on earth would you go through the massive headache, the astronomical risk, and the logistical nightmare of trying to build bleeding-edge, liquid-cooled AI data centers in a mountainous, earthquake-prone region?
This raises an important question, and it's the crux of the financial argument in the manifesto. It all comes down to the economic multiplier effect.
The multiplier effect.
Yes, if Nepal built a dam and exports a megawatt of raw electricity across the border, they are participating in a basic commodity market. They capture the baseline regulated price of wholesale electricity.
Which is fine, but it's not revolutionary.
It's reliable, but it's very low margin. You're essentially just a utility provider for someone else's industrial base.
Right.
But if you refuse to export the raw electrons and instead feed that clean baseload megawatt directly into a localized cluster of AI GPUs, you are performing an act of digital alchemy.
Digital alchemy, I like that.
You are taking a raw, low-margin physical commodity, literally water falling down a mountain, and instantly refining it into API calls for frontier AI models. You are creating one of the highest value digital products in the global economy.
So, to use an industrial analogy, it's the difference between a country exporting raw bauxite or for pennies on the ton versus refining that bauxite domestically into aviation-grade aluminum and selling aerospace parts.
That's a perfect parallel. You capture the entire value chain domestically. Converting that clean energy into AI compute creates extraordinary value. Power comes first. Without it, those expensive GPUs are just heavy paperweights.
And the text emphasizes that these AI factories have highly specific operational requirements that actually align perfectly with this geography, don't they?
They do. These facilities require immense baseload power, meaning power that doesn't fluctuate.
Right, unlike solar or wind.
Exactly. Solar drops off when the sun sets, wind dies down. But training a massive AI model takes months of continuous, uninterrupted computation. Hydropower provides that ultra-stable baseload.
And what about the cooling? We talked earlier about the brutal thermal load of these new chips, 100 kilowatts a rack.
This is where the geographic argument gets even stronger. If you build a gigawatt data center in the American Southwest or the Middle East, you have to expend a massive percentage of your energy just running the chilling plants to keep the servers from overheating.
It's a parasitic load. You're wasting power just to cool the power.
Exactly. It kills your efficiency. But in the Himalayas, you have access to ambient sub-zero air and endless glacial runoff. You get effectively free, natural cooling, which dramatically lowers the power usage effectiveness, or PUE, of the facility.
But wait, the logistics? I just keep thinking about hauling racks of $100,000 GPUs up mountain roads. That sounds like a nightmare.
Oh, it's a brutal engineering challenge, no question. Which is why this isn't a typical software startup pitch. It is a heavy civil engineering pitch, intertwined with advanced networking.
Yeah, that makes sense.
But the author's logic is that the cost of overcoming those logistical hurdles is vastly outweighed by the decades of cheap, zero-carbon power you secure on the back end.
Because power is the ultimate constraint.
Right. You can buy the GPUs if you have capital.
Yeah.
You cannot just invent a 50,000 megawatt clean energy grid in the middle of California. The power constraint is so severe globally that it literally forces the infrastructure to move to where the energy is stranded. Regions with abundant renewable energy are poised to become the new global strategic hubs.
Effectively redrawing the economic map of the world.
Exactly.
The audacity of the vision is striking, but honestly, the corporate structure they're aiming for is what really caught my attention. Himalayan Compute doesn't want to be a software company.
Not at all.
They explicitly state they have zero interest in building software or competing on algorithms. They want to be a utility. They want to be the foundational layer that everyone else builds on. And the text makes a very specific, ambitious comparison to Amazon Web Services, or AWS.
For a technically literate audience, the AWS comparison is the fastest way to convey the scale of what they're attempting.
Right, because AWS changed everything.
It did. Before AWS, if you wanted to launch a software startup, a huge chunk of your seed capital went to buying physical servers, racking them in a colocation facility, and hiring network engineers to maintain them.
It was a massive drag on innovation.
Amazon realized that server capacity was essentially an undifferentiated heavy lifting task, so they turned it into a utility grid. They abstracted away the physical hardware.
They told developers, don't buy servers, just plug into our massive centralized data centers and pay for the exact compute you use by the second.
And it birthed the modern cloud. But the manifesto argues that while AWS was the definitive utility for the internet era, the AI era will require something even bigger.
Here's where it gets really interesting. Just imagine for a second, to you listening. Imagine intelligence itself becoming a utility. Just like you turn on a tap for water, future businesses, hospitals, and nations will basically buy intelligence on demand.
A profound shift.
I really want to break down their logic on the technology stack here, because this is where the author tries to justify the astronomical valuation potential. They argue that the lower you sit on the tech stack, the larger your total addressable market.
It's a structural law of technology ecosystems.
Yeah.
At the very top of the stack, you have applications.
Okay, applications.
Right. If you build an AI application for, say, summarizing legal contracts, your market is strictly law firms.
Makes sense.
Below applications, you have platforms. Maybe an AI platform for natural language processing that developers use to build various apps. That's a larger market.
Sure.
Below platforms, you have the infrastructure layer, the servers and databases. But at the very bottom, beneath everything, is the utility layer, the raw power and base compute.
Because the legal app, the medical imaging app, the autonomous drone navigation system, they all ultimately have to buy raw compute to function.
Precisely. If intelligence becomes a utility, the providers of the compute become the providers of intelligence. You are taxing the entire ecosystem.
So they are proposing what exactly?
The author poses a genuinely radical question. What if AWS is not the ceiling, but the floor?
Wait, really? That is a staggering proposition. We are talking about a company that effectively powers a massive percentage of the modern internet. Suggesting AWS is merely a baseline seems almost detached from reality.
It sounds absurd until you look at the delta between the internet economy and the projected AI economy.
Okay, break that down for me.
The internet, for all its massive scale, primarily digitized commerce, communication, and media.
Right. Websites, emails, shopping.
But artificial intelligence, in its mature state, is projected to digitize and optimize physical cognition across literally every industry in science. We are talking about constant real-time inference for millions of autonomous vehicles, robotic manufacturing, automated scientific research, molecular simulations for material science.
The internet was about moving data. AI is about continuous active computation on that data.
Exactly. The sheer volume of compute required to run a fully integrated AI economy could dwarf previous generations by orders of magnitude.
Oh, wow.
If that thesis holds, and if you manage to capture a foundational slice of the global utility layer powering it, $1 trillion valuation isn't a magical assumption. It is simply the mathematical consequence of capturing market share in the largest industrial expansion in human history.
But capturing that market share requires a shovel hitting the dirt, right?
Which brings us to the brutal reality of execution. To build a utility, you need a moat. And the text leans heavily into the idea that massive capital requirements are actually a feature, not a bug.
Yeah, utilities are incredibly hard to replicate because they require enormous capital and operational excellence.
Exactly. Once a railroad or a power grid is built, competitors face massive hurdles. We have to look at the historical precedent of infrastructure monopolies. Look at the expansion of the telecommunications grid or the laying of transatlantic submarine cables.
The initial barrier to entry is just terrifying.
It is. You face catastrophic upfront costs, ruling regulatory battles, complex land acquisition, and years of negative cash flow before you onboard a single customer.
It's the absolute antithesis of the modern software startup.
Completely. A software startup wants to raise $2 million, build a minimum viable product in 6 months, and iterate based on user feedback with near zero marginal costs.
Move fast and break things.
Right. But you cannot move fast and break things when you are building a gigawatt hydropower data center complex.
No, you definitely cannot.
But that exact friction is what protects you. Because once you endure the pain of building that infrastructure, once the turbines are spinning and the fiber is lit, any potential competitor has to face that exact same terrifying barrier to entry just to challenge you. The capital intensity becomes a fortress.
Which perfectly frames their initial funding ask. I was looking at the pitch document, and it outlines an immediate goal of raising $100 million.
Right.
Now, for a normal startup, $100 million is a massive later stage round. It's a Series C or D meant to scale a proven sales team. But here in this manifesto, it's called mere ignition fuel.
Ignition fuel.
Yeah. For a project of this scale, 100 million doesn't even buy you the servers. Can you translate this into traditional venture capital terms? What exactly is this money doing?
If we connect this to the bigger picture, you see why traditional VC models fail to comprehend infrastructure. Traditional VCs are used to low capital, fast scaling software. The 100 million here isn't for the final vision. It's to start the flywheel. It funds the massive geotechnical engineering studies required for mountain data centers. It secures the land rights, the water rights, the early government permitting, and perhaps the construction of a small-scale proof-of-concept facility.
You are buying the right to play the real game. You are creating momentum.
Momentum is the only currency that matters in mega projects. Once you use that ignition fuel to prove you have the land, the permits, and a viable design, you have de-risked the project enough to attract the real money.
The big players.
Right. The customers, the sovereign wealth funds, infrastructure, private equity, those entities write billion-dollar checks, but they won't touch a project until the initial foundational work is complete. The 100 million is the spark that starts the engine.
Which perfectly transitions into the psychology of investing, right? Because at the seed stage of a civilization-scale project, the risk is astronomical. You have no revenue, massive regulatory hurdles, and unproven engineering in a hostile environment. Why would anyone write a massive check for something so seemingly absurd early on?
It's a great question.
The text spends a significant amount of time addressing this, invoking the philosophy of exponential investing and going from zero to trillion.
The author anchors this argument around a concept championed by Vinod Khosla.
The venture capitalist.
Yes, one of the most successful in history. Khosla frequently advocates for looking for, quote, $0 billion companies.
Which, on its face, sounds like a terrible investment strategy.
Right.
Why would I want a $0 billion company?
It sounds like a guaranteed way to lose your money. But the underlying philosophy is brilliant. A billion-dollar company already has its value baked in. If an investor looks at a company that is already widely recognized as a billion-dollar asset, the market consensus has already priced in that success. The potential for exponential fund-making returns is largely gone.
You're just buying a mature asset at retail price.
Exactly. A $0 billion company, on the other hand, contains sheer possibility. It's an entity that the broader market currently values at nothing, usually because the consensus views the idea as impossible or absurd.
But hidden within that collective dismissal is pure, unpriced upside.
The greatest venture returns in history are generated precisely in the gap between when an idea is considered ridiculous by the mainstream and when it becomes blindingly obvious.
And the manifesto provides some incredible historical context for this. I was so excited reading this part. We look back at massive successes as if they were preordained, but they were almost universally mocked at inception. Look at Amazon in 1997. If you told a Wall Street analyst that an unprofitable online bookstore was going to build the logistics and server infrastructure to dominate global commerce, you would have been laughed out of the room.
Or consider SpaceX in 2002. The consensus among aerospace experts was that a private startup attempting to build reusable orbital rockets was a ridiculous, physically impossible idea.
Right.
Or Tesla in 2008. The entire legacy automotive industry believed electric vehicles were a niche pipe dream, and Tesla was literally on the brink of missing payroll.
So what does this all mean? It means the future looks ridiculous before it looks inevitable.
And this requires a specific psychological framework from the investor, which the text calls the trillion-dollar filter.
The trillion-dollar filter.
Yes. When a standard risk-averse investor evaluates a pitch like Himalayan Compute, their brain immediately defaults to identifying points of failure. Most investors ask, what is the downside?
They see the earthquake risk, the geopolitical complexity, and they pass.
Exactly. Their goal is capital preservation. But great investors, visionary investors, force themselves to ask a secondary, far more important question. What if this works?
Ah, right.
They explore the paradox of risk versus reward. If there is even a 5% chance that this team can actually execute, lock up 50,000 megawatts of cheap green power, and build the foundational utility layer for the global AI economy. The mathematical upside is so staggering that it justifies the initial capital loss if it fails.
Human nature wants proof. We crave certainty. We want to see the historical cash flows, the proven unit economics.
But by the time a transformative shift is proven and obvious to everyone, the exponential financial upside is gone,
Yeah.
captured by the people who are willing to look foolish a decade earlier.
Yeah, as we analyze this document, we have to address the elephant in the room.
Yeah, we do.
Because if you read through the Netizen Manifesto and look at the surrounding materials, this isn't just a dry business plan or a sterilized corporate pitch deck drafted by McKinsey.
No, it is not.
It is framed with grand, almost prophetic language. The very first line boldly claims that the age of abundance was prophesied in the scriptures thousands of years ago.
It's a very jarring shift in tone.
Yeah. You go from reading about liquid cooling metrics and AWS infrastructure comparisons directly into sidebars revealing books and concepts by the author linking AI to Kalkiism, Solar Vision, and these sweeping geopolitical changes. It reads less like a standard pitch deck and more like a techno-spiritual manifesto.
It is deeply unconventional.
Yeah.
And as analysts, our responsibility is to carefully and impartially unpack this.
Right, without taking any sides.
Exactly. It's crucial to separate the underlying economic argument, the arbitrage of converting stranded hydropower to compute, from the ideological packaging. We are evaluating the physics and economics of the infrastructure play. We aren't endorsing Kalkiism or any political view.
But we shouldn't just ignore the framing either. I mean, why package a multi-billion-dollar infrastructure pitch in prophetic language?
Because, historically, civilization-scale infrastructure builders often possess a grand, borderline utopian belief system that drives them to attempt the impossible.
They operate inside a reality distortion field.
They have to. When you are trying to rewire the global economy, the friction you face from governments, physics, capital markets is so crushing that a standard risk-adjusted mindset would dictate you quit on day 3.
Yeah, any rational person would walk away.
To sustain the brutal, decade-long slog through the ridiculous phase, extreme ambition often requires a deeply unconventional worldview. The grand, sweeping vision is the necessary mechanism to recruit the true believers, secure the initial capital, and simply survive the psychological toll.
You need zealots, not just employees, when you are trying to build a trillion-dollar utility from scratch in the Himalayas. The ambition is just breathtaking.
It is the definition of a foundational bet. Most tech startups are trying to build a slightly better feature. This project is attempting to build the substrate that every future feature will run on.
Wow. This has been an incredibly dense, massive journey of a deep dive. So let's pull all the threads together to recap. We started by transitioning our mindset right, shattering the illusion of the weightless AI software cloud, and grounding ourselves in the brutal, heavy physical realities of power grids, specialized cooling, and concrete.
And we explored the mechanics of the compute economy,
Right.
understanding why raw processing power is destined to become the ultimate global export of the 21st century. We dissected the highly specific, counterintuitive geographic superpower of Nepal.
The economic alchemy of converting water to compute.
Exactly. And we analyzed the utility business model, questioning whether AWS is just a prelude to a much larger AI infrastructure monopoly.
And we grappled with the high-stakes psychology of exponential infrastructure-level investing, going from 0 to trillion, and why investors must endure the social friction of backing ridiculous ideas.
The primary takeaway for anyone listening is to permanently alter your perspective on the digital tools you use. The next time you use a seamless AI tool, look past the screen. Recognize the vast, roaring industrial machine running behind the scenes.
The turbines, the fiber optics.
Exactly. Understanding this hidden physical layer is key to understanding the future economy.
The digital sports car is useless without the physical gas station. It's a total paradigm shift. And to leave you, the listener, with a final provocative thought to ponder something that builds on the text but pushes it even further.
Let's hear it.
If the core thesis of this manifesto holds true, if compute truly becomes the new oil and regions with abundant green energy become the new superpowers, how will this shift global geopolitics?
It's a huge question.
Will we see an OPEC of AI emerge from developing nations with massive renewable resources? Will a coalition of countries armed with geothermal, hydro, and solar reserves suddenly seize the choke points of global intelligence, finally flipping the historical balance of power away from legacy tech hubs?
It's a fascinating thought experiment.
It sounds like science fiction today, but as we've discussed, the future always looks a little ridiculous right before it changes the world. Thank you for diving deep with us.